Welcome back to che205. In this video, I'll be talking about the solution of exam 1. So the first problem is to find the root of a function, which is basically very similar to example 1.6 of the textbook. I think 1.6 or 1.7. So we have a gas made of 4 components: ethylene, ethane, propane, and butane. We have the coefficients of so-called Antoine equation, A, B, and C for every component. We have also the mole fraction, Zi, given on the bottom of this table. So for every component, we can calculate the partial pressure Pi using the coefficients of Ai, Bi, Ci. All right, so for example, if we want to calculate the ethylene partial pressure, then I put Ai, or basically A1, B1, and C1 in here. For a given temperature, I can calculate the partial pressure of ethylene. Okay, so using the partial pressure, we can calculate the so-called equilibrium constant, which is partial pressure divided by the total pressure, which is given, and that is 15 atmosphere. All right, so now, given Ki and Zi, where I goes from 1 to 4, we can construct this equation 1 minus sum of Zi over Ki. In principle, that is going to be 1 minus Z1 over K1, Z2 minus K2, Z2 over K2, Z3 over K3, Z4 over K4. We subtract this sum from 1, and that is, we call it f of t. Okay, so f of t is a function of temperature. For every temperature, we can calculate the f. However, for a specific t, which is called dew point, that f is 0. So the goal in part B and C is actually to calculate that dew point, where f of t equal to 0. For part A, we are only supposed to calculate the f for various temperature. We are not setting f of t to 0 yet. So in part A, we're going to calculate f of t for different temperature from 270 to 350. All right, let's see how we can do this. So this is a solution posted on Blackboard. I have the table here, so this is exactly copied from the problem statement. To calculate f of t, I have to first calculate the k's, and then z over k, which I call u, and then subtract the u's from 1. And that's what I have here. So then I have k's. For every temperature, I can calculate k. And then for every k, let's say for this k1, I can calculate u1, which is basically u1 is z1 over k1, u2 is z2 over k2, and so forth. Okay? And then as long as I have u's, I can calculate f of t, which is nothing but 1 minus, so this part is u1, minus this part is u2, minus this part is u3, and minus this part is u4. So if I have u's, then I can calculate the f. So I'm going to go over one of these rows. I think the rest would be similar. So let's look at K1. What is K1? Well, K1 by definition is Pi over P, and Pi is 10 raised to the power of Ai minus Bi over Ci plus T. And these are all given from this equation. If the log base 10 of Pi is this, then Pi would be 10 raised to this power. And that's what I have here. So then K1 is going to be 10 raised to the A1 minus B1 plus, B1 over C1 plus T, and that's up to here. And then divide all of them by the given pressure, which is P. All right? So which indices we have to freeze? Well, pressure is fixed, so both indices are frozen, the letter and the number. All other ones, we only freeze the letter index because I want to be in such a way that if I drag this cell and If I grab this cell and drag it to the right, the indices for K2 should be now in column C. The indices for K3 should be in column D, and so forth. So for every cell that I go to the left, to the right, it has to be the same way in the table. That means if K1 is referenced to these three cells, then K2 should be referenced to these three cells. And you see that as I go to the right, these columns actually go to the right as well. Well, they have to be shifted to the right, or we have to use the right columns, right? So that's why we do not freeze the letter index, because going from this column to this column means B should be replaced by C. And going from this column to this column means C should be replaced by D. And because of that, I don't freeze the letter index, but the numbers are all frozen, right? Because if this K1 is linked to A1, B1, and C1, right, K2 will be referenced to A2, which is sitting in the same row of A1, and then B2, which is sitting on the same row of B1, and then C2, which is sitting in the same row of C1. So the rows are frozen. The rows are not changed, but columns will change, and that's why we don't freeze the letter index, except the pressure, which is fixed regardless of temperature. Okay, so that is K1. As soon as you create K1, you can grab this cell and then move it to the right until you get to K4. So far we calculate K1 to K4. And what is U? Well, by definition, we said U is Zi over K1. Well, Z1 over K1, Z2 over K2, and so forth. Right, so this part is U1, this part is U2, and then 1 minus U1 minus U2 minus U3 minus U4 will be F. And that's what I have here. So U1 is pretty much Z1 over K1, and I'm only freezing the letter index because when I drag it to the right, I want to have columns shifted as well. So I calculate U1 to U4, and then F is nothing but 1 minus sum of these four cells. So you see that 1 minus sum of these cells, that is F of t. I create a column from 270 to 350 with a separation of 10 degrees. And as soon as I calculate this, then I highlight all these so let me clear this up. So I highlight all these cells and drag all the way down. There you go. So you get the curve. It should be looking like this, where it hits the x-axis almost close to 330 degree Kelvin. So that's perhaps the root. We're going to see it in part B and C. So let's move on. In part B, I'm going to do the goal seek. So all you do is you implement the equation for ft we had here now, basically on this row. So all we do is just, you can copy this cell, right? And then, well, I have the pressure written here. So based on that, you can copy these cells like this, and then paste it here. So I do paste special, and then so let me cancel that. Let's look at K1. So K1 is exactly what we had before, is 10 raised to the A1 minus B1 over C1 plus T, and that's what I have here, divided by the pressure, which is now this cell. So you write the equation for K1, you drag it all the way to K4, and then U1 is nothing but Z1, which is this cell divided by K1, which is that cell, that is Z1. Alright, so I'm going to drag this guy also to the right to get U1 to U4. These are all based on temperature that I have here, and then F of t is nothing but the 1 minus sum of the u's. So there you go. We do goal seek. We set this cell, we go to data, what if, goal seek, and then we set this cell to 0 by changing this cell, right? That's the temperature. We go, and that's the solution we get. So you can start with, let's say, 320, like, I don't know, that's 200, that's a guess. And let's do the goal seek one more time. So here's goal seek. I'm going to set this cell to 0 by changing this cell. And there you go. So the solution should be 326 degrees Kelvin. So that is part B. And then the last part is part C, which I think most students had problems. And I think the major problem was how to get the derivative of f of t. So we know how to calculate f of t. The only thing is how to get the derivative of that. So let's go back to the function. If I want to get the derivative of f of t, which is this function with respect to k, I have to get the derivative of each term with respect to k. Z's are constants, so basically I have to get the derivative of k with respect to t, right? And I have calculated here. So let's look at how we can calculate the derivative of f. So I just said that derivative of f is z1, so that we can use the rule for the fraction. So the derivative of f is the derivative of 1 over k1, because z1 is constant, is not dependent on t. Derivative of k1 with respect to t is negative of 1 over k squared derivative of k1 with respect to t. Okay, so far I have to calculate derivative of k with respect to t. Now derivative of k with respect to t is derivative of pi with respect to t, because p is constant. So p is not changed, that's why I have pi here. I'm sorry, p is not changed. That's what I have. That's what I have. P here. So p is not changed. I have to get the derivative of pi. Derivative of pi means derivative of this with respect to t. So this is 10 raised to some function of t. And some students actually had problems here. They didn't know how to get the derivative of 10 raised to some power. So the best thing is you Google it. So here is the Google search of 10 raised to some power of t. So I'm going to show you here. So this is the Google search I did. It's very simple. If you just type exactly what you're looking for, I said derivative of 10 raised to some power like f, which is a generic function of t. Okay? And then you get a couple of videos, which I don't recommend. There are two links actually here. One is, the second link here says, what is the derivative of 10 to the raised power of x? I'm going to click on that. And look at that, the very first line of it is exactly what you need. What is the derivative of a raised to u? And u is a function of x. So that's going to be log of a times the function itself, which is a raised to the power of u, and then du dx. So that's one link, the very first line of it. You go back, even if you go to the third link here, list of derivative rules from UC Davis Mathematics. If you go in there, then let's scroll down a little bit. And down here, exponential derivatives, you see that the first line here in this section is, in fact, actually this is more generic. I like this one more. It's a raised to the function of x. And derivative of that would be, again, a raised to the function of x, same as before. So that's the original function f, times the derivative of exponents, and then times log of a. Okay? So we're going to perform the same thing here. Let me move this website over. Okay? So the derivative of k1 with respect to t will be derivative of the exponent here, which is bi over ci plus t squared. So that's the derivative of exponent times the function itself, which is pi, right? And then log of 10, which is log of the base. This division by p is actually coming from ki. Remember, we have to take the derivative of k1 or ki, and p is not function of t, so it stays there. So you can simplify this further, right? You can, right, so then pi divided by p, this is already k1. So you can simplify with that k1, and so forth. So we can do a little bit of simplification here. All right, so that's how we can calculate the derivative, okay? In the next video, I'll be completing this section and show you how we can really find the root. So stay tuned, and thanks for watching.